And I'd like to introduce and welcome Phyllis Saarinen, who will introduce our speaker for today.
Good afternoon, and thank you everyone for attending the 5th of 6 sessions on climate change. What does it mean for civilization? Dr. Hal Knowles is our speaker this afternoon. He describes himself as a change agent and trim tab. I hope he will explain what that means. Trim tab. With his multiple research and teaching interests, primarily regime shifts within linked complex socio-ecological systems and resilience and adaptation to change. He works within the UF program in sustainability and the built environment and is an instructional assistant professor in the College of Design, Construction, and Planning. Among other positions, he's also a faculty fellow of the Florida Climate Institute, a past fellow of the Florida Natural Resources Leadership Institute, and a board member of the PTA at his children's elementary school. With his teaching load and other commitments at UF and within the community, as well as a family that is recovering from COVID, he's a very busy person. I greatly appreciate his taking the time to speak to us today about climate change as a catalyst for an emerging regenerative economy. He received his PhD and MS in interdisciplinary ecology from UF School of Natural Resources and Environment, and his BS in construction management from the Rinker School of Construction. Thank you, Dr. Knowles.
Thank you so much, Phyllis, and everyone with the IRL. It's really a privilege to be here today. Can everybody hear me okay?
Yes.
All right, excellent. I'm going to try to cover as much ground as I can. I'll probably move fairly quickly through some of the slides, but they'll be left as a resource for you. They'll have hot links embedded in them. And then I want to make sure I leave ample time at the end for some more interactive Q&A. It's always hard to figure out how to curate what I want to say. So let me go ahead and share my screen first. All right, great. So as I get started now, what I always like to do is kind of give a little context for myself and how I got into this journey. As a kid, growing up in Orlando area in Central Florida, I grew up looking up at the stars and imagining if there was another child sitting on a planet around some star I could see in the sky, looking up and imagining if I was out there looking back at them. And that was kind of the beginning of me dreaming of maybe being a part of kind of reaching out and learning more and being part of kind of expanding our knowledge and exploring the universe. And I dreamed of maybe being on the first human mission to Mars, watching the space shuttles go up on the Space Coast, and wanted to be part of engineering the habitat. I wanted to be the habitat module specialist and help that team to create a sustainable and resilient habitat there on Mars. And if any of you have seen the movie, The Martian with Matt Damon, you know that he beat me to it, at least sort of in story context. And the thing that's interesting about this story and that I think is really important when we're thinking about sustainability issues is it's really a story about how he, after being kind of left for dead alone there on the planet after a disruptive event, an uncertain emergency, he had to figure out how to survive. And it was a story of solving one problem after another. And I always tell my students that sustainability is experience-based, value-derived problem-solving process. And each new solution that we create for a problem becomes the seed for the next problem, right? The solutions need to sort of be prioritized hierarchically and always kind of putting out that hottest fire. And that's kind of what Matt Damon does in this fictional story that's, I think, also grounded in a lot of kind of real world ideas of science. And so I didn't get to be on that first human mission to Mars. And of course, at my age now, I realize that's not likely to happen. And over the course of my career, I realized that my purpose maybe was actually being part of the habitat module specialists here on Spaceship Earth and trying to figure out how to manage this place. So there's a great quote, and I'll give some context for the trim tab here in a moment or later in the presentation. But Buckminster Fuller once said, whether it is to be utopia or oblivion will be a touch and go relay race right up to the final moment. And I think that for me, this is a really important quote because as a systems ecologist and a systems thinker, I really resonate with the things that Buckminster Fuller brought into our world and the ideas that he shared. And he's also trying to help us realize that we need to simultaneously balance the severity of the problems that we face. They are real and they shouldn't be minimized. But we also need to recognize that there's hope and that all of these problems are actually catalysts and they're giving us feedback for how we interact with the system, and they're catalysts for changing our behavior and doing something different. And it's always kind of touch and go about whether this new paradigm will replace the old one or not. And so in 1990, I think it may have been 1999, the Union of Concerned Scientists wrote a book to try to help all of us at sort of an average layperson consumer level try to make better choices about how we can reduce our burden on the planet and on each other. And they wrote this book called The Consumer's Guide to Effective Environmental Choices. And in this book, they through their studies, surmise that there are 7 activities that we as consumers engage in that are effectively the most important, most pivotal choices that we make in our lives. These are the 7 most impactful things that we do in modern society. And these 7 things lead to 4 major consumption problems. And climate change is embedded in this broader context. So those 7 consumer activities that we engage in are how we move from place to place: cars, light trucks, obviously the difference between single occupant vehicles on a crowded highway at rush hour and mass transit that's electrified, like this light rail in Houston, are going to have a very different environmental footprint and a very different quality of service for people. So that's one of the 7. 2 and 3 of those 7 are related to our agricultural system. One is kind of meat and poultry and dairy, livestock related things. And then the second would be sort of more plant-based agriculture, fruit, vegetables, grains. And then the 4th item would be home heating, hot water, and air conditioning. So basically how we make that interior space comfortable. Then there would be household, number 5 would be household appliances and lighting, all those sort of plug loads. Number 6 would be the home construction itself. And you can imagine the building envelope, which is sort of the exterior walls that separate the interior comfortable spaces from those exterior, stressors that we have and we're trying to protect ourselves from with our buildings. And then the last one, number 7, is household water and sewage. So effectively water, right? Water related issues. And so these 7 things contribute to 4 major problems. Number 1 is air pollution. And this is not the same thing as climate change. This is air pollution in the context of particulates in the air, local smog. This is probably a photo of vehicles on a cold day. And so it's probably mostly condensation that you see here, but it's a great visualization for what comes out of the tailpipes. And as a cyclist here in town, and we have lots of bicyclists and pedestrians on campus, this is obviously a challenge right there at ground level. It's why smokestacks at a power plant are so tall, because historically for engineers, the solution to pollution is dilution. So if you get it spread out and you get it at a high enough sort of altitude, it'll kind of diffuse over the local area rather than be kind of like you're choking on a tailpipe directly. Number 2 is climate change, and that's obviously what we're sort of here about today. But all the things that I'm sharing really are sort of embedded in all of these issues. And climate change is but one source of feedback about maybe a deranged way that humans are relating to the world around us. I like to show this. I'm not going to talk about the science of climate change. I know that you all being here are very interested in it and probably know about it quite well already. But I like to show this image because as a multi-generational Floridian, it really resonates with me because these coastlines are 3 coastlines of Florida. And I typically ask my students if these are past, present, and future, and they tend to say that C is the past, B is the present, and A is the future. And interestingly enough, these are all 3 the past. They just happen to be different points in the past. Coastline A is actually the furthest past, and that's approximately 110,000 years before present, the Wicomico shoreline. And that was at the last peak interglacial, meaning that it had melted down. And so the state of Florida was about 1/3 the size that it is now. Coastline B is the present day, and yet this book was written in 1990 that I pulled this map from. So it's 30 years ago, and the coast is constantly changing, dynamically in flux every day. Coastline C was about 20,000, 25,000 years ago. The Wisconsinian glacial shoreline, that was the last peak glacial cycle, meaning we had a lot of water locked up in the ice caps. So Florida has constantly been changing, and it's just a representation of what happens all over the planet. So climate change is not new. It's not something that that the planet hasn't gone through before. What is fundamentally different is that now humans, in the midst of the Anthropocene, which is this era of geologic history on the planet, where humans are the prime mover of change, we now are the main forcer of that system and the speed and direction of its change. And that's the challenge, right? Then the third problem is habitat alteration because of the way that we change the land use itself. I'm not going to get into too many details, and you can look at the references here to go read the full report if you'd like. But I've got a series of images that show some research into Florida from 2010 as the baseline all the way up to 2070. And they try, so this is the 2010 baseline. Red is developed areas. Green are conservation areas that are in some sort of easement and they're protected. And those are not beyond being able to change, but they generally, suggest those areas are likely to stay undeveloped and protected in the in perpetuity going forward. And then the light green other are areas that are not necessarily protected in a legal standing. Maybe they're private but undeveloped landscapes, maybe agricultural or silvicultural or otherwise. This is what Florida looked like. Geoplan Center and 1,000 Friends of Florida collaborated to come up with these different scenarios. And this, you can see the extent of development in 2010. This is what Florida is projected if we continue the pattern of development that we've had over the last 50 to 60 years, if we just project forward and develop in the same way. Again, toggling back and forth. I don't know about you all, but I certainly don't like the idea of my kids growing up in a state that looks like this. And obviously it's a beautiful place. We attract people in. So we want to make sure that we can accommodate that population without damaging the habitat in the process. And in their study, they also came up with an alternative scenario. So here's the baseline, or excuse me, the trend, business as usual. Here's an alternative where we can try to protect more of the state's landscape. And then again, even in the alternative scenario, some change is inevitable, but we still can make better choices. Number 4 of these 4 problems that came from that Union of Concerned Scientists guide is water quantity. And this issue in the baseline, you can see here the level of gallons per day per acre that are consumed, often more than half of irrigation at a sort of household level in the state of Florida is in the landscape itself. So less than half is inside with cooking, cleaning, bathing, flushing toilets, and more than half is outside. So a big indicator here is how we choose to create our landscape. So here's the trend if we continue business as usual. And again, you can see lots of new development expected that would probably have in-ground irrigation and be problematic. So that's a fairly manageable thing that we can potentially change with better practices. And then you can see the alternative scenario tries to reduce that. Then the second half of this 4th problem, where the first half was water quantity, the second half is water quality. So that's kind of the pollution side of things. And this is a photo of the lower St. Johns River near Jacksonville from 2005 during an algal bloom. And historically, we've kind of said those algal blooms, pollution in waterways was due to big agricultural polluters. But as we continue to urbanize more and more, it falls on the shoulders of us, householders and the landscapes that we create. And this is obviously degrading the water quality and impacting economic livelihoods, health. It causes toxins in the air that can cause respiratory distress, and it can cause damage to the ecological habitat. So when we take all of those things into account, what I like to kind of talk about is how we have this opportunity to take these 7 activities that we engage in. You can kind of break them down to 4 fundamental things that human and non-human animals alike all share in common, which is the need to eat and drink, the need to dwell, the need to move, and the need to commune. And commune both sort of communicate between each other in kind of an interpersonal sense, as well as communicate inwardly in an intrapersonal sense through sort of our own spirituality and ways of knowing beyond sort of the world that we can tangibly measure, right? And so we are influencing the resource stocks and flows across natural capital, energy, water, and material capital, as well as human capital, social capital, financial capital, and the like. And I kind of draw this here as if it's a funnel so that we can imagine as we appropriate those resources and we start to use their stocks or at a certain flow, we're basically enabling these 4 activities through the 5 stages of production, processing, distribution, consumption, and post-consumption. And then how we go about doing that leads to a series of outcomes. And I kind of think about them as, edges of a spectrum, almost kind of a yin and a yang, a positive and a negative kind of affectation of those opportunities. So you can think of economic livelihoods. A sense of opportunity would be a positive, adaptive, beneficial thing, and a point of constraint would be a negative or maladaptive thing. From a standpoint of health, well-being would be the positive, adaptive response. Malaise would be the negative. From a standpoint of social equity, fairness, the positive, injustice, the negative. And all systems are constantly in flux and leading to outcomes along these boundaries, along these spectrums. And those influence, change, and exchange with what systems ecologists are sort of referring to as the 9 planetary boundaries. Those are effectively climate change, novel entities, including sort of chemicals, nanotechnology, nuclear waste, all sorts of things in that context. Stratospheric ozone layer, which we've actually had a chance to try to influence our negative impact on it with some more positive behaviors. Atmospheric aerosol loading, which was related back to that air pollution one that we talked about. Ocean acidification, which is a kind of a byproduct of climate change, as the ocean, which is our biggest planetary carbon sink, absorbs all of that carbon and in some ways helps us to slow down the rate of climate change by limiting the amount of CO2 in the atmosphere. We're stressing the ocean ecosystem and actually driving it into a higher level of acidification, which may break down the shells of diatoms and other carboniferous organisms, and that would have a profound effect on the ecosystem. Nitrogen and phosphorus flows related back to that water quality issue that I previously talked about, and obviously related to runoff and sewage and the like. Freshwater use, again, coming back to the quantity side. Land use change, which we talked about. And then biosphere integrity and this notion of diversity and sort of redundancy in the ecosystems themselves. So you can see here an example of what the planetary boundaries look like as of 2015. And at one point, the stratospheric ozone depletion a couple decades back was actually up here past the red threshold. And we've since drawn it back down, which is a really great thing. And that suggests to us that there's capacity in the Earth and its subsystems for some degree of kind of self-healing of the systems if we can continue to find ways to draw back our negative impact. It's as if we're pulling at a scab and continuing to open up the wound, and that's why these systems are at that stressor past this sort of safe operating space, right? So I'll talk about that in just a moment. When we're thinking about sustainability, another key aspect here, another key concept is the notion of resilience. Sustainability requires us to protect things that we value, and resilience can be beneficial and complement sustainability, but can also be contradictory to it, because to be fully resilient, we wouldn't be able to hold on to values. We'd have to be able to sort of let go of the things that we find important if it's necessary to keep our system to be able to adapt to the uncertainties of change. And there's some key principles when it comes to resilience thinking. Those core principles include maintaining diversity and redundancy. So bringing that down to earth and an example at a household level, we can try to make the system really efficient. And if we make it too efficient, it starts to become brittle. I think we have a good example here with COVID, with the global economy, this whole notion of the just-in-time economy, where everything was kind of, just a day or two out from delivery. One little disruption in the case of, let's say, computer chips causes major cascading failures down the system. Efficiency is great from a sustainability standpoint. It's actually sometimes bad from a resilience standpoint if you go too far down that path, because you make the networked systems brittle. So there's some degree of diversity and redundancy that can help the system. Managing connectivity, right? So systems that are most adaptive are also deeply networked and connected. And that can be beneficial to many extents because it allows information and material and other flows to move quickly, but it can also be problematic. It can be kind of a double-edged sword, and we see evidence of that with misinformation, disinformation, and other things with regards to social media. We're so connected now, we can actually, bad ideas or untruthful ideas can spread, in a viral way that could be damaging. Manage the slow variables in feedback, right? So this is where this notion that climate change, which is a long emergency, this slow variable comes back to help us realize, okay, how do we start to think more like our ancestors, the many indigenous communities that look several generations into the future in their decision making. They try to imagine how their decisions now will play out, not just 5 years from now or 50 years from now, but several generations forward, pushing hundreds of years from now, right? So how do we manage the feedback from these slow variables like the climate that, on any given day or year, it doesn't seem to be that dramatic in what we need to do? Foster complex adaptive systems thinking. And this gets into a broad suite of things that I won't talk about here today, but the notion that complex systems are interconnected, that there's uncertainty is inevitable, that emergent properties arise. These critical aspects come into play. Encourage learning. And I think as an instructor here at the University of Florida, this one's important for me. And I try to tell my students to the best degree I can, what I'm really striving for is actually not teaching them really anything. I want to help uncondition the things they've already learned so that they can start to think more creatively and more broadly and out of the box again, because the challenges we have are so complex that we can't solve them at the level of thinking that created them. We need to move much deeper beyond that. Broadening participation, the Arab Spring, these other uprisings that have created an opportunity for sort of, a groundswell of people to say, we don't want to stand for this, we need a better future. These are important aspects in resilient systems, but they also need to be managed, and connections are critical. Promoting polycentric governance is the last of these 7 sort of resilience thinking principles. And this is the idea where we need to respect this sort of nested integration at the scales, city and county, all the way down to sort of local scales, into state, federal, and international scales. And that we need to respect that those are all playing off of each other and all cross-pollinating. And that we're constantly learning. Everything we do from a policy standpoint is an experiment. It's a hypothesis, and sometimes it works and sometimes it doesn't. I think there's some things we did with COVID protocols that worked well, and there's some things that we learned some lessons that maybe we would do things slightly differently in the future. And that's an important aspect of resilience. So fitting into that polycentric governance is this notion of the Sustainable Development Goals, the 17 key goals that the United Nations has created to help guide some of these metrics that we would want to track from the standpoint of sustainability. So this brings me to one of the last things that I wanted to say in kind of setting up the tone here as we get going, is this notion of the donut model of economics that Dr. Kate Rayworth and all of her collaborators have created, where they've taken the science of the planetary boundaries, which you see out here, the 9 planetary boundaries, and they've integrated the notion that not only is there an ecological ceiling that we don't want to push beyond, but there's also a social foundation that we don't want to fall below. And so in a sense, we kind of occupy this, this donut in the middle from the standpoint of trying to create livelihoods, right? What we're trying to do is create the safe and just space for humanity and trying to create a regenerative and distributed economy by keeping our operations, how we eat, how we dwell, how we move, and how we commune within this safe space. We don't want to push the ecological ceiling into overshoot, and we don't want to let any of these 12 foundational metrics from a societal level shortfall at, again, local, state, federal, international scales. So if you want on your own, your own exploration, there's some links here in the slide deck that will be shared with you. that help us to better understand some of these principles of donut economics. It's really deeply tied in with resilience and systems thinking, moving from 20th century economics into 21st century, where it's not linear, it's cyclical, where it's systematic, it's socially adaptive, it's based on dynamic complexity rather than this very simplistic notion of equilibrium. It's distributive by design, it's regenerative by design, and it's growth agnostic, meaning we don't need a sort of a whole economic paradigm that assumes that perpetual exponential growth is possible. It's not. No living system does that. All living systems, just like our body, from youth, it takes a while for us to kind of, as infants, to grow, and all of a sudden we accelerate in our growth, and it's exponentially faster in body mass and height and other things until it starts to flatten out, and then it sort of plateaus in this S curve, right? And so we need an economic model that starts to think more like that. So if we want to think about how we thrive rather than grow, the key is to recognize that climate change, though an alarming phenomenon that we need to be paying attention to, we should not let it drive us to fear, but rather let us focus on it as feedback and as a catalyst for a regenerative economy that wants to emerge. I think this is where humanity's going. And I like to tell my students that this regenerative economy, to me, is kind of this, what I call HT squared. It's high tech squared. The first high tech is the one we're familiar with from the Industrial Revolution, which is technology, right? And all of the things that come with machine learning and innovations in science, technology, engineering, and mathematics. The second high tech is high TEK, which stands for traditional ecological knowledge. And that's basically all of these things that are embedded in our genes and the memes of our society. So the genes are sort of the building blocks of our physical bodies, and the memes are the informational building blocks of our society and culture and the way we communicate. And traditional ecological knowledge is built on a much longer legacy, thousands of generations of human history rather than 3 or 4, 5, 6 generations of human history since the Industrial Revolution. So this brings me to this need, to recognize that we always have to assume, again, coming back to the point I made earlier about problems, and as we solve them, complexity. Science is sort of our best problem-solving endeavor, and I think to some extent, that communion with each other. But there's always diminishing return. So as we increase complexity, let's say the electric grid as a form of complexity, it starts to create, challenges as well, and there's diminishing returns. So we always have to recognize that at some point, each new level of complexity, the jump from this point to this point of complexity led to this amount of benefit to us societally. But then the next jump, which was maybe 2 times bigger jump in complexity, led to half as much benefit until you reach the inflection point, and then every new added level of complexity starts to degrade our benefit and actually cause worse outcomes. And this is where this balance of high tech technology and traditional ecological knowledge comes into play, because it's that traditional ecological knowledge that becomes the moral compass that helps us from pushing over that threshold. Conveniently, I tend to be an optimist, and there is evidence in sort of our history that suggests that we have just-in-time innovations and revolutions where just before we start to pass that threshold, and it looks kind of scary, like we're going to come down into a collapse because we didn't recognize the diminishing returns, or the negative returns, I should say. They're diminishing all the way up and they're negative on the way down. What happens historically is that we create a new wave, a new paradigm of innovation that replaces the prior one. So early waves here, like iron, water power, mechanization, textiles, commerce, slow and low. And then eventually on its way down, that gets replaced by this next wave, industrial revolution with steam power, railroads, steel, cotton. It's a little bit faster and a little bit steeper. And then the third wave comes, electricity, chemicals, internal combustion engine, again, a little bit steeper, a little bit faster. The fourth wave, a little bit steeper, a little bit faster. The fifth wave, now we're up to digital technologies, biotech, software and information tech. And we're in the midst of this sixth wave, which deals with things like sustainability, radical resource productivity, whole systems thinking, regenerative and renewable innovations. And you can see that the speed of innovation needs to be more profound and happen faster. And so this is challenging, but it's also what drives us to innovate. Okay, so this brings us to Project Drawdown, which is kind of referred to as the most comprehensive plan ever proposed to reverse global warming. And this is where we start to look at climate change as a positive catalyst for change. Project Drawdown is this, or Drawdown as a concept, is this milestone when planetary greenhouse gases hit their peak and begin to decline year to year through human enterprise and ingenuity and activity. It's not merely addressing climate change to try to slow down the rate of our burden on the system, nor is it trying to cap emissions, nor arrest the emissions, all necessary but insufficient. It's rather trying to sequester and draw them back down. That's a much deeper challenge, but it's also a much better constraint by which to drive innovation in what we do. So their goal of this project, and we teach our entire curriculum in the unit I'm in at UF around this book, is to identify, measure, and model 100 substantive actionable solutions within 3 decades, from 2020 to 2050. So all of these ideas are seeds of potential benefit for society. They're all things that work at a fairly digestible scale, often a smaller scale. And the question is, how do we scale them up? These are not necessarily things that we're waiting and need innovations to align. What we need to align is the human will to start to make them manifest in our society. How do we usher them forward? Because they seem to work at smaller scales. How do we scale them up to change our impact on the planet? So the whole book is kind of based on this idea that we need a rigorous plan. We need to stop just talking about it, and we need to emulate examples like what we saw in California, where in 2006 they set a goal to reduce emissions to 1990 levels by 2020. And as of the time the book was written, they were on track as of 2018. And their 2016 goal, they actually increased it to reduce emissions to 40% below the 1990 baseline by 2030. And again, there's lots of positive examples where societies are shifting and making progress. So the solutions must be this mix of technological, ecological, and social. And Project Drawdown uses this mix of systems thinking and detailed analytics, and it's evolving in real time. Another thing that I really like about this textbook, and Paul Hawken and his collaborators who wrote it, and is that they really focus on the importance of language. And they reference this quote here from Confucius: "The beginning of wisdom is to call things by their proper name." So Drawdown aims to bridge the communication gaps. It's designed for a lay audience. It tries where possible to avoid confusing analogies and jargon and minimal acronyms, right? To say things like methane, not CH4. They also try to shed light, put light on the common and all too easy sort of knee-jerk reaction to use negative phrases and sort of aggressive phrases when talking about the climate challenge and drawdown, right? Decarbonization is not a really sensical word, since we're all carbon-based life forms, right? We're not trying to decarbonize anything. We're just trying to shift the flow and function and scope of change and how carbon is moved around in systems, right? We're not creating negative emissions. There's no such thing. We're going to try to sequester emissions. And we're also not going to use violent or military language, things like a war on carbon, fight against global warming, frontline battle against fossil fuels, combat, crusades, because these create, again, knee-jerk reactions where you tune out the people that we're trying to change. You may get the preach to the choir and get the people that are already on board to feel good about it, but you're not going to change anything for the people that are resistant. So for Hawken, the Earth's climate is, and always will change. As I showed you that, that graphic from Florida, that was only 110,000 years of change in Florida. It went from 3 times bigger to three times smaller, right? So it's changing. We're just a part of that change. So anthropogenic global warming at the Earth's surface must be reversed. And for him, it's this idea that climate change is not happening to us. Like, poor me, poor us, we're victims. climate change is happening for us. It is the planet telling us that we need to change ourselves. And I think one thing to me seems clear. One of two ways of change is going to play out. We're either going to change the planet into something that the humans have never known, or we're going to change humans into something the planet has never known. And so we're either going to change by disaster, which is the first one, or by design, which is the second one. And if it's by design, then we're going to do it consciously and conscientiously, moving forward to try to change the way that we interact with each other and the systems that we're a part of. So in Drawdown, the top 29 solutions and 71 others, and this was when the book first came out in 2018, they've since come up with an addendum. And so some of these are actually shifting around as the science gets a little bit better. And so I think refrigeration may not be number one now. It may actually have slid down one or two spots. And now I think food waste is near the top. But these are very surprising, right? You think historically that energy is the prime mover, and this is what we need to change, is the way that we use energy in our economy. And sure enough, they see lots of examples. You know, the refrigerants that we use and their global warming potential is a big problem. And that fundamentally has to do with how we space condition both our buildings and the vehicles that we move around in, right? But you can see some big ones here as well. You know, wind turbines, onshore. These are things that you would assume, solar farms, rooftop solar, but then you also see some really interesting ones that are related to land use and food, right? Like reducing food waste, a plant-rich diet, silvopasture, regenerative ag, conservation agriculture, and the like. And then you can see they even have some, you know, human development issues here and social justice ones, like educating girls and women and family planning at a global level. And they actually have science that suggests that we have a very positive you know, drawing down impact on the climate when we empower girls and women to be able to make better choices and plan their families and not be sort of forced into, you know, household servitude. So they create three different scenarios. In the original one, I think they now sort of have two scenarios. The plausible scenario, which is the case where the drawdown solutions are adopted at a realistically vigorous rate, adjusting for economic and population growth. And then the drawdown where they're optimizing it to achieve drawdown by 2050, and then this more optimal one where they're sort of really pushing forward in a progressive, positive way. So at the time that original one came out, and again, these numbers are slightly shifted, I probably need to update my slides. You can see how these ranked. In the plausible scenario, refrigerant management was 1, but by optimum scenario, it shifted down to 3, and all of a sudden wind turbines popped up to 1, forestry, and a variety of other things. So these are the things that we need to focus on. This is how we need to create a regenerative economy. When we say regenerative, we mean sort of cyclical, where, you know, everything that you look back at, that production, processing, distribution, consumption, post-consumption, that sort of 5 outer sections of that sort of funnel that I drew for the 4 fundamental actions that animals engage in: eat, dwell, move, and commune. That's cyclical as well. The waste of that process becomes the food for the next step. Okay, so this now what I'm going to do, and I'm probably going to move through this faster than I would like because I want to open it up for some Q&A within the next 20 minutes or so, right? I'm going to break this up into the 4 sections that we talked about, right? So this is going to be move to arrive, eat to thrive, dwell to survive, and commune to self-realize is the way that I like to say it. All right, so the status quo right now sort of looks like this. It's very car-centric. And at the end of the day, we design our urban environment for the benefit of the machine rather than the occupant. And at the end of the day, what we really want is the service of mobility from one place to another. And how we get there doesn't often matter, right? But this is obviously bad for the planet. It's bad for people. And I would argue at the stage we're at economically and culturally, it's bad for those things as well. And then if we look back historically, you can imagine, and this is an Aborigine in Australia, and this is giving an example of sort of where we've all come from in the standpoint of our mobility prior to the Industrial Revolution. It was beneficial to our health because we were walking around on foot. We didn't need a phone to tell us how to navigate. We knew how to read the landscape. We knew how to understand and relate to the system. And the whole process of colonialism and colonization, we leveraged the traditional ecological knowledge of these people and kind of appropriated it sometimes when it was to our benefit, and then in other times tried to suppress it altogether by educating out their historical knowledge. And we need, part of the social justice movement is recognizing that we need to re-welcome all that is indigenous, not just in the cultures that we've maligned, but also in ourselves, because we're all derived from that, right? And then this is kind of not the status quo, and it's not the past. This is kind of the near future, or maybe the present day better practices. Maybe it's not yet best practices. This is a photo from Tokyo that I really like, because it shows this example where this street is still partially designed for the vehicle, the automobile, but it's also designed for people. I mean, this is a massive crosswalk. You've got pedestrians, you've got bicyclists, you've got collapsible bikes. Increasingly, you might have, electrified mobility from, scooters and skateboards to electrified bicycles. You've got electrified mass transit, this light rail right here. This is multimodal mobility infrastructure is what we're talking about here. And as we go forward further into the future, we're going to start to realize that all of these mobility corridors are not really just about us. We're going to move from them being designed to serve a vehicle to designed to serve human beings to designed to serve life itself. And when we get to the point where our transportation corridors serve life itself, we realize that information is not just a human thing, that plants and animals are exchanging information in their gene flow and how they forage and move through the landscape. And how do we get multiple services out of those corridors, such as vegetation that's aesthetically pleasing, that helps to capture water, that helps to grow food. The campus here at University of Florida, we have edible plants. And I tell students all the time, and they don't always know it, that when things are in bloom and fruiting, you can grab the citrus or the fig from the tree and eat it. That's why it's there on campus. How do we make more of that? How do we regenerate these landscapes? How do we start to integrate stormwater, low impact development, green infrastructure, where we're actually having pervious surfaces where the water can percolate back down into the soil rather than sheet flow off and create floods like we saw in Houston after Hurricane Harvey. That's a maladaptive event that was, it's a tragic event that happened as a maladaptive response to too much hardscape and not being able to predict such a massive stormfall event, right? So a key aspect of thinking about how we move to arrive is thinking about energy metabolism. And so it's really important that we understand that we're all just sort of this flux of energy, our bodies themselves, as well as the entire planet, right? And the energy literacy principles that the DOE has are based on 7 things. Energy follows natural laws. The earth itself is an organized system of energy flows. Life depends on those flows. Humanity is powered by diverse sources of energy. Our energy opportunities are defined by ecology, society, and economy. Our energy use is complex and multifaceted, and the energy choices affect the quality of all life. Historically, what we would do, again, innovate to produce more, to solve more problems. One human laborer has the power output of about 75 watts or 0.075 kilowatts. That's one person. Well, to be able to keep up with the growth of the human population as we shifted from hunter-gatherers to agrarian and pastoralist societies, we couldn't keep up with the need for procuring food from the habitat around us. So we started to domesticate animals. And one ox can do the equivalent amount of work of 6 people. And one horse is the equivalent amount of work of 10 people. And then you can think about horsepower in a vehicle as kind of a proxy for the number of people power that vehicle has, right? And you can see here wind power and steam and the modern automobile, right? So there's this whole idea of being able to relate to this in the sense of human power, right? So how do we commute? So here's an example. This was a Prius that we had for work, and now we're moving to EVs. But you can see here shifting to pedal power, human power, going back more like our sort of ancestral lineage, like that Aborigine who's walking by foot and knows their way around. One human traveling at 14 miles an hour commuting to work is the equivalent of 0.1 horsepower, right? Because it's 1/10 of a horse from a power potential. 0 pounds of CO2 emission, other than maybe some methane from the meal that I ate, right? And then a 22-minute commute. Well, in the process of switching over from driving a lot to biking a lot, I dropped 40 pounds. I think some of it was also lifestyle changes and dietary changes. And that would be, if I had driven this energy efficient vehicle, it would have been the equivalent of 110 humans at 20 miles an hour. It would have resulted in 2.7 pounds of CO2 emissions for that 5-mile commute. And it would have only saved me 7 minutes. It's as if I would have been behind a chariot with 1,100 human beings taking me to work. So even, we always have to remember this notion of technology and traditional ecological knowledge, and it's always going to be both and. We need both of these solutions, and we need to know when each is the most meaningful. When we're thinking about fuel economy, what we're trying to do, changing to EVs, is not just beneficial because we're switching off of fossil fuels, right? To some extent, yes, it matters what's happening at the power plant. If we're combusting fossil fuels there, there's still a carbon footprint until we get to renewables, but it's much less, right? So an engine, the losses, 100% of the power potential in the fuel going into a vehicle, in urban driving, only 4% of it actually contributes to forward rolling motion, which means 96% of it is lost in all of these other inefficiencies of the system. 7% on highway driving is the result. So highway driving is in some ways a little bit more efficient at converting it to forward motion, but it also takes more energy in there. So EVs, electric motors, are more efficient in converting the input energy into forward motion. And they're also more resilient because electricity is not an energy source, it's an energy carrier. And it can be created from an innumerable type of amount of energy sources, right? So you can make electricity, as we know historically, from natural gas, coal, nuclear, biomass. There's lots of ways you can make electricity. You can also make it with renewables like solar and wind and wave. And so switching an economy towards electrification is inherently diverse, which means that we're not stuck on one fuel source. We can create electrons from a variety of ways if the end use equipment is electrified. So we're going to see that increasingly moving away from natural gas burners and water heaters in your house to fully electric things, because they're more efficient and they're more resilient. Also, this notion of multimodal transit, the importance of having infrastructure for that. An example of this where it helps and regenerates our health as a society is the Portland example. Just checking on time here. Commute, they increased or decreased the number of miles that were driven by vehicles. They also saved over $1 billion, 800 million of which stayed in the local economy in Portland rather than going to multinational fossil fuel companies. Reduced the budget burden by 4% compared to the national average because it's less costly, and increase the satisfaction with their mobility networks. So I'm going to go ahead and scoot through some of these, and you can look back at them later. But these are some images that talk about the benefits of cycling to our health. And the challenge that we have here in Florida, where 5 of the top 10 most dangerous metropolitan areas for pedestrians are here in Florida, including my original hometown of Orlando being the worst. So again, trying to understand some of the challenges here with pedestrian deaths. And the other thing that I wanted to mention here is this notion of, the system serving us. If you look at these two charts, the top one is energy consumption, the bottom one's greenhouse gas emissions. Here, the most efficient source of mobility is the urban diesel bus with the lowest emissions down here and energy consumption here. And then the worst performer is also an urban diesel bus. It can be both the best and the worst, and it just depends on how many people are on it. If it's riding during peak, when every seat is full, it's down here. If it's driving around empty or with 1 or 2 passengers, it's here. So the solution is not just public transit, it's public transit that gets used, right? And Chevy Suburban burning fossil fuels with 7 occupants is a more efficient per person per passenger mile than a single occupant Toyota Prius. So we have to always sort of think strategically through all that. We have to remember there's a profound challenge and opportunity as we shift towards an electrified mobility sector. Historically, vehicles didn't eat out of the same food bowl that our buildings did, right? They're kind of like cats and dogs. They were, they were generally using oil and gas, and our buildings were using electricity from coal and natural gas, not gasoline, and a variety of other things. And now we're increasingly seeing this fusion between these two sectors. Just wanted to mention there's lots of innovations as we shift towards electrification. We're now seeing electrification in mining equipment, electrification in farming equipment. One of the interesting solutions that comes with this kind of synergy of things like electrification for mining equipment is one of the biggest costs for mining, dealing with protecting the workers, is getting all the emissions out of the mine from burning fossil fuels with the vehicles. And now these are quieter and they're emissions free, and they're safer for workers to harvest the materials that they might need to get. We're also moving towards, slowly but surely, autonomous electrified vehicles where they're fully connected both to each other and to the infrastructure around them. Notions of the Hyperloop, which is a vacuum reduced, near vacuum tube that has a series of pods that float on an electromagnetic rail. It's basically a maglev, and can move faster than an airplane can fly through the sky, because they're in a low friction environment, both between maglev and the vacuum in the tube. And so this kind of technology, we're still at the early days, but the science seems promising. We may be able to travel much faster with much less emissions, even than air travel across maglevs. There's also innovations in sort of seafaring mobility. This is a company called Candela. They're from Sweden. They have created the world's first electrified hydrofoil boats. They're now scaling up. This is a real boat. There's lots of great videos online showing them. They're scaling up from passenger boats, speedboats like this, to ferry boats to go across all the archipelagos in the Scandinavian countries. And it is dramatically more efficient, 90% more efficient than a conventional boat, because you're basically flying through the water on a foil with an electric motor rather than the hull of the boat. There's also dramatic savings, estimates 90% emissions reductions in cargo container shipping by revolutions in sail technology. If anybody watches the World Cup, if you see what they do now, they're basically hydrofoils. And rather than a fabric sail, they now have carbon fiber sails that look like wings. And they are considerably faster than they ever used to be years ago. And that same technology is coming to the shipping industry. All right, so now let's talk about the dwell to survive. Historically, this is what housing looked like. This is pretty dehumanizing. It's not very efficient. It's not resilient. We've got examples from Hurricane Andrew where, deficiencies in the building code, where the windstorm was high enough that it caused failures in roofs across the board. There's no redundancy. There's no diversity in this kind of housing. Historically, this is what housing might have looked like for humanity. In this case, this is extremely resilient. It's based on regenerative materials that are cyclically used and can go back and regenerate back into the system. It has the capacity for passive solar heating and cooling. They can open this here so the heat can rise out, and they can roll up the bottom and allow that cool air from the ground to come up and exit through the top. They've got their food being preserved out here in the air, and they can also roll up and modularly move their housing with the seasons to follow the sort of what the system offers them. As we started to westernize and industrialize, we started to shift and become a little bit less nomadic and more sort of sedentary, but we still had some meaningful principles, right? Like keeping the hot kitchen that creates humidity and fire over here separate, and then having the living quarters in here, but still having shade structure, still having an elevated floor so that you could have that cool ground, air underneath the house, keep it cooler. Having the sleeping quarters on the east side of the dwelling unit and the living quarters, the daytime quarters on the west, so that you're taking advantage of that sort of ambient solar radiation, the sun rising in the east and heating that part of the house up. Well, this part's cool, so then you move from the sleep time over to here. And then as this part heats up at the end of the day, you're moving back to the cooler side where the bedrooms are. Well, that same principle, we took that traditional ecological knowledge that was originally from, the indigenous wisdom, and then the Florida Cracker vernacular, which is called that dog trot house. Students in the School of Building Construction competed in the solar decathlon in Spain, and they basically created a modern rendition of the dog trot house. Sleeping quarters on this east side, living quarters on the west side, solar up top. So how do we take those principles and instill those into a regenerative economy? It's going to need renewables and other technologies and more efficient HVAC systems, but it's also going to need, indigenous traditional knowledge of how the sun moves through the sky. What does the landscape offer? How do we design buildings that are going to be more resilient and efficient? How do we leverage things like the chimney stack effect of a cupola at the top of a building? Like you can see if you go to the summer house at Kanapaha Botanical Gardens, it's this kind of construction. So it's a mix of high technology and high traditional ecological knowledge. So we need more systems thinking in the way that we go about doing things, where everything is sort of communicating with everything else. And this is an example from General Electric and talking about the different technologies, electrified technologies they have, but you start to see economies of scale and efficiencies that come with these different opportunities. There's also some really neat things happening when it comes to efficiency and in design, right? So again, traditional ecological knowledge, circular structures. Our indigenous ancestors didn't have squared off boxes that they lived in. They lived in things that were more natural and more organic, and this is basically riffing off of that. You've got a geodesic dome, which Buckminster Fuller kind of innovated and invented as a design idea, and these webs are made of bioceramic, which is also a new innovation that's been around for 50 years as an idea, but it's finally coming to fruition. And this is a potential replacement for concrete and Portland cement as we know it. It's stronger, and it actually sequesters and absorbs carbon over time. And they're trying to, this is a company, full disclosure, I'm a small investor in this particular company. They're a small startup out of California, but they're trying to create these modular geodesic domes that can be hand built with fairly modest labor on site. So I'm going to quickly sort of zoom through these, and you can look back at them at your discretion, but these are some resources here that talk about the sort of reference home, where energy use plays out across that home, and what we can do to try to address that. And you can see, leakages and gains, attic and ducts, solar windows, and other things. So the next series of slides, again, that I'm just going to zoom through, and you can look back at your reference, provide several steps for how you might go about trying to reduce your burden climatically and energetically in your property. Sustainable dwelling, both a noun and a verb. Audit, act, and adapt, right? You're going to want to engage in ways that you can better understand, leverage tools, leverage technologies to better understand the performance of your building. Then you're going to want to seal all of those points of air infiltration and exfiltration. Where's the air leaking in and out of the building? And how do you seal that up so you have better control over that? It doesn't mean that you want to live in a tight cave. You still want fresh air, but you want it in the way that you can control it. You want to take advantage of technologies, right? Like blower door testing and duct blaster testing to better understand the building performance. Here's an example of duct blaster testing to see how the ducts are leaking, and then repairing them with better insulation and better mastic and other sealing that reduces the leakage rate into the attic, or better yet, don't have an unconditioned attic in the first place. You're also going to want to insulate, ramp up that thermal barrier to reduce that heat exchange between indoor and outdoor environments. You want to evaluate and replace the windows. And these are sort of stepwise, right? So you're obviously doing the earlier steps first because they're low-hanging fruit, less cost, and better return on the investment in a sense, right? Windows are expensive, and we generally recommend you only replace them when it's either a safety issue or an aesthetic issue or a malfunction issue, or in new construction, you try to put in the best windows that you can that meet the kinds of criteria you see here, like the U factor being low, the solar heat gain coefficient being low, the visible transmittance being high, and the air leakage being low. And so you can see some examples of how also knowing, again, traditional ecological knowledge on the north-facing windows, you can potentially have some less efficient windows from a U factor and solar heat gain coefficient than you might have on the south, east, and west, because it's not getting direct sunlight through this window, right? Maintain and upgrade the HVAC, again, addressing things like the refrigerant issues. We're starting to see innovations rather than refrigerants that have many, dozens or hundreds, or some cases, thousands of times higher global warming potential than carbon dioxide. We're seeing some innovations where they're creating carbon dioxide as a refrigerant. So its global warming potential is 1. It's equal to any other form of carbon. And eventually we may get to solid state heating and refrigeration, which is another innovation. Maintaining and upgrading that water heater. We're increasingly seeing even things like solar water heating, solar hot water, being replaced by a conventional electric heat pump, hybrid heat pump water heater with solar panels, because the panels creating electricity are more efficient than simply heating up the water with a lot of expensive copper pipes. Upgrade fixtures, fans, and appliances, taking advantage of services like Energy Star so that you know your options. And at the point, as a consumer, that you replace any technology, it's always great to try to put in the most efficient technology that meets your current needs. And so again, things like understanding the water heater types, understanding how air conditioners work, potentially putting in heat pumps, maybe even ductless mini splits, and some other technologies. This is a slide I share with my students to kind of describe that, government policy and regulations are not a villain if they're done in a thoughtful way. They actually can inspire innovation. And you can see here that energy use and refrigerate, which is the orange line, and refrigerator size were on the rise up until the mid-70s with the first energy crisis. And then we started to integrate a series of federal and state legislation to try to reduce the energy limits. And you can see here that over time, the refrigerator price, though early when they were doing the research, really spiked. Since then, it's slowly but surely, even controlling for inflation, has been decreasing at the same time that refrigerators have still increased in size while dramatically reduced their energy profile. We're getting our cake and eating it too. It's a lovely example of how public policy and regulation can be a thoughtful constraint to drive innovation in the private sector. So the key is finding that balance. Okay, so I'm gonna just want to see what I got ahead. I want to try to cover a handful more here. You'll have lots of other slides you can look at, but I wanted to mention here the energy opportunity. Obviously, in the Drawdown book, onshore wind is number 2 here in Florida. We don't think about wind as being a potential innovation. And you can see that our wind speeds are pretty low, and so there's other parts of the world where wind is potentially much better. Again, you can see the same thing here, right? We don't have a lot of capacity listed by 2014. But again, innovation, it marches on. And you can see here, as we're moving, and we already have this first wave of the future, this 150 meter tall wind turbines are already starting to be installed. And we're not too far away from being able to realize 250 meter wind turbines, meaning that's where the sort of peak of the turbine gets. And look at the difference here when you get to a hub height from 110 meters in Florida to 140 meters. All of a sudden, Florida starts to look like a place where you can actually have wind turbines as well, because now they're getting up to a high enough elevation that you can start to generate some wind. Offshore wind, number 22, we're now starting to see even here federally some policies being implemented that are suggesting we're going to start to become an innovator in offshore wind as well, and not just cede that innovation to the Scandinavian and European countries. There's some stats in here about levelized cost of energy to help you see that that solar, especially utility scale solar, is now among the cheapest electrons that a utility can put on the grid. So utilities are not installing solar for the good of their heart and because they want to be sustainable and green-minded. They're doing it because the bottom line economically suggests that putting any more coal-powered utility plants online is a loss leader. They're going to lose money in that innovation. And so there's a lot of other ones in here that talk about that. So with that said, I wanted to jump forward here. And when we, in the next 5 minutes or so, I want to open it up for questions, but I want to let you know that I also walk the talk, and in a prior house that my wife and I occupied in 2008, 2009, we became the first solar feed-in tariff customers here with GRU and installed a 3.85 kW PV system on the house. And so I certainly have some thoughts that I can share and reflect about that. We're increasingly moving towards this reality where solar plus, this notion that solar plus batteries is going to be critical. And the thing that's innovative, that's really exciting, is that we're going to very quickly move away from even things like the Tesla Powerwall, this stationary battery that gets installed on the wall in your garage. It's not even going to be necessary, because eventually our vehicles themselves are just going to be batteries on wheels. And there's no need to have a stationary battery when your vehicle itself is dramatically bigger. The new Ford F-150 Lightning truck, it's the all-electric Ford truck. It has the capacity to share 9.6 kilowatt of power in real time. And that's way more than a typical house here in Gainesville would need in real time. And it has a 100 kilowatt hour battery pack. It's going to be possible to power your house off the battery pack in that truck. And they have the inverter infrastructure to allow that bidirectional flow, not just to charge the truck, but to power the house. That vehicle could power a typical Gainesville house for somewhere between 4 and 7 days without power. All right, so let me jump forward again, and I wanted to talk a little bit here about the agriculture example. Obviously, the Eat to Thrive, we've moved, present day, it's this kind of tragic monoculture where we're poisoning the land for a selective series of crops, and we're not feeding anybody but ourselves. But our ancestors, the earliest human art around the world, are images of wildlife that we revered because of the nutrition that they provided us. These were orarchs, which were sort of, they're extinct now, but they were very large, sort of, equivalent to cattle and buffalo. And our hunter-gatherer ancestors relied deeply on them for their sustenance. We eventually domesticated them, became pastoralists. But even early Florida livestock looked a lot more like this. It was a true habitat, and the livestock were just one animal in a broader functional habitat. It did not look like the confined area feeding lots that you see and that give meat a bad rap, and rightfully so. The animals are dying, they're being poisoned, and I think that the food poisons us at the end of the day. But some of the best habitat that's preserved here still in the state of Florida is on legacy cattle ranches. And if the owners of those properties can't continue to ranch, they're going to just convert that land into houses, and that's not going to solve any of our challenges, right? So how do we start to think more holistically about food systems? This is, baby lettuce, and it's important to note that even a 1 pound container of baby lettuce takes 4,600 calories of fossil fuel energy to grow, chill, wash, package, transport to a plate on the East Coast. So it takes 57 calories of fossil fuel energy for every calorie of food. That's because those systems look like this. It's a big, mechanistic system that's laser leveled from a satellite in space to cut all those baby lettuces at exactly the right height. So this notion that only a vegan or vegetarian diet is a sustainable diet is a misnomer. It can make sense for some people, and I get it, and I love the ethics and appreciate it. But there's also options for people who choose to eat meat or feel that it's necessary to eat meat for spiritual or health reasons to still have better options. And so I share some resources in here that provide some context for that. I'll show a couple of them in here just to show you. But there's resources in here like links to TED Talks that talk about how we can reverse desertification by using livestock to restore habitats. And there's some examples where they've restored habitat in Africa that looked like this, that was turning into desert. And then they did appropriate livestock management, much more like true savanna ungulate animals would be moving across the landscape, and they were able to regenerate the habitat. And I've taken students to White Oak Pastures about 2 hours north of Tallahassee, which is a regenerative ranch that's actually had independent analyses done to look at their carbon profile. They're vertically integrated. They have abattoirs, the slaughterhouses on site that were designed by Temple Grandin for animal welfare purposes. They sell their meat at Publix, their ground beef, and they are net negative. They are absorbing and sequestering more carbon in the soil than their entire operations, both the methane coming from the cattle as well as their operations are emitting. And I've taken waves of students up there to visit this ranch. There's also examples of restoring the Great Plains with perennial grasses and grains rather than annuals. And you can see the difference here between the roots of an annual wheat, which is this one on the left that has to be replanted every year, often with proprietary grain like Monsanto, right? Or perennial, that's much more like the ancestral natural habitat. We could restore the habitat. And then there's examples as well of companies that are starting to capitalize on ecosystem services and use innovations like blockchain, which is behind the technology behind Bitcoin, but there's lots of different ways that distributed ledger technologies get used. They're going to try to start monetizing ecosystem services so ranchers and landowners can also get value out of restoring the soil and sequestering carbon and rejuvenating and regenerating the hydrologic cycle on site. They can now start to value that and get sort of made whole in that process. There's also a great TED Talk here from a great chef in New York that's famous for his farm to table restaurants, where he talked about trying to find the perfect, most sustainable fish to put on his plates. And in doing that, he discovered this fishery in southern Spain that is managed like a habitat. And they actually let 30 to 35% of all of the fish that they're raising go to the predation of birds and other wildlife, because they complete the system and they require no supplemental feed. The system feeds itself. So there's lots of examples of how we're doing regenerative ocean farming. Some great links here if you want to learn more about how we can do regenerative ocean farming. Urban agriculture, really great TED Talk here about a guerrilla gardener taking back blighted landscapes in LA. And again, coming back to that prior image and this notion that the whole transect from the most rural and natural to the most urban, we have lots of opportunities to integrate food production. And of course, what we do is going to be different at each part in the landscape transect, right? Obviously, forageable wilderness, transitioning into tractor farms, hand-tendered farms, yard gardens, all the way up to window boxes and the like. And I think maybe what I'll do is stop there. I've also got a section in here on how we commune to self-realize. I'll kind of leave it at this and open it up for some Q&A, and I'll make sure that Phyllis and everybody have all of these slides.
Thank you so much. That was fascinating. And I like having something positive to think about and hope for. I'm also concerned about the fact that the political economic system is full of rigidity because of those who benefit from the current status quo also have the power. They have the political power. And I'm thinking about Joe Manchin, for example.
Yeah.
The other aspect is the very complex system that has been exaggerated by social media, because the more points of interaction there are in a complex system, the more it tends towards chaos. And I think we're seeing that politically. The Trump movement, other movements such as the blockade that's occurring in Canada, those kinds of things are all facilitated and enhanced by social media. And I hope we can get it together. I mean,
yeah.
I have a grandchild.
Yeah, and one thing, and I want to make sure I get to answer some questions for the hands that are up, but I want to make one comment about what Phyllis was saying. Something that I always try to stress with the students is this idea that we need to be more mindful and meet people where they are and be less judgmental. And I try to use this example where if we walk around trying to help manifest a more sustainable world, and we say everybody needs to be a vegetarian or everybody needs to drive a really small, we have a BMW i3, it's a real tiny little towny vehicle, it only gets 80 miles of range, but it's perfect for in town, right? But there's lots of people, I've worked in construction management, there's lots of people that need a pickup truck for work or choose to have it to be able to travel and pull an RV. And some people want to eat. I choose to eat meat. I have an ancestral lifestyle, but I choose to try to eat regenerative meat. So the key is choice. Give people choice, I think, meet them where they are. You know, eventually they're going to come to make those changes when they start to realize that their life is getting better. I mean, I think all these sustainable things that we want, they're actually going to be making everybody's life better. And I think we're just going to show them by just doing it. There's a great quote here. Actually, I should have brought it in here. Let me show this one slide, and then we'll do the questions, because this one slide will give it some context. So as we're trying to shift from the old paradigm, so everything that Phyllis was saying, you know, kind of the notion of Trumpism and the blockades and all this, this is an old paradigm, and it's going to go away, and this is going to collapse out, and the new paradigm is rising underneath that, right? And to be able to help people not feel like not fear the notion that their way of life is slipping away, we have to build a bridge to connect them to the new paradigm that is emerging. And another great quote from Buckminster Fuller is, you never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete. All the automobile companies laughed at Tesla and said, you know, we don't have to compete with them. And now they're all in catch-up mode, because Tesla built a better model and everybody else is now trying to catch up to it. And so the trim tab example, a quote that Phyllis talked about, Buckminster Fuller, basically, let me come back up to the slide where I have the exact quote that he had in it, to tell you the trim tab quote. So it's, where is it? But the quote from Buckminster Fuller is basically that imagine a big shipping container ship, and you're trying to turn this ship. The size of the main rudder is so huge that it takes too much energy to turn the ship. It's the same thing with an airplane, the wing. The little teeny pieces at the edge of the wing are called the trim tabs. And it's the same thing with a big ship. The tiny little rudder is the trim tab. And when that takes much less energy to move that. And then when that starts to move, it changes all the currents and all the eddies around either air and water to move the big trim tab. And we can assume the big one is society writ large, governments writ large. All of us are the tiny little trim tabs. And so Buckminster Fuller is trying to say that we actually have the power, that we're the ones that move the big ship through all the little actions we take every day. So with that said, I'll hand it to Phyllis for facilitating questions.
Okay. Well, I like the analogy. Okay, so one person remarked that she just recently bought a hybrid. She was talking about an electric vehicle, and the dealer told us that the Florida infrastructure to charge vehicles in Florida is wanting. It doesn't really exist.
Yeah, so what I can say is that from the things that we've looked at, Tesla's infrastructure is, at the moment, Tesla specific. Only Tesla vehicles can charge on it. Tesla's infrastructure is very good, and it is national. You can drive from South Florida to Maine to the Pacific Northwest to Southern California in a Tesla, and it will tell you where to charge and where to go, and it is there, right? And it's continuing to expand over time. Some of the other competing networks, Electrify America and others, are slower. They're a little bit behind, but the infrastructure is there. But what I can tell you is what really matters is how you're going to use the EV. So we have a Toyota Prius, which is a hybrid, and then we have the BMW i3, which is 100% battery electric. The Prius is what we use for longer road trips, and when we're visiting family in South Florida or something. And the BMW is what we use around town, because most days we travel way less than 80 miles in a day, which is the range that it has. And so you don't need to worry about charging infrastructure. I plug it into the same wall socket I would plug my cell phone into, and it charges up overnight. I think it's scare tactics, you know, and the key is understand worst case scenario. I think we maybe drive long range, maybe 5-6 weekends a year. And if need be, I'd be willing to rent a car for those weekends if I felt like my EV wouldn't do it. But I think that infrastructure problem is overblown, and it's changing rapidly.
Yeah, and also the infrastructure bill provides for charging stations, but
Absolutely.
I don't know how long that's going to take. But anyway, I don't know who came in first with the 3 questions or 3 hands up that we have, but can we start with the ladies first? Alice?
Thank you. I just want to thank you, Hal. The talk you had was very interesting, and I have a comment and a question. And the comment is, you mentioned about the circular houses. And I just wanted to reinforce that when Hurricane Charlie hit Southwest Florida, they showed the scene of a development where there was one circular house and the rest of the houses were decimated and the circular house was barely touched. So I have really wondered why we don't stress that more, especially in Florida. And that brings me to my second question. Do you do any presentations to city planning groups?
So currently I'm a lecturer, instructional assistant professor in the College of Design, Construction, and Planning. I've been here for about 4 years. But prior to that, for about 16 years, I was in the UF-IFAS Cooperative Extension. And I was in a statewide role where we would work with builders, developers, and local governments around the state on green building, sustainability, community resilience issues. So at that point, I was doing a little bit more kind of engagement with various key stakeholders. Right now, I'm kind of holed up in a classroom and I don't get to do it quite as much as I'd like. But I try to, and some of my prior colleagues at work, we do try to do that. And I'm partly housed out of the urban planning unit as well. So I do have some opportunities to do more of that, and I would very much like to. But we're trying to help developers see the light on these opportunities. And on this, the thing that's interesting on the circular homes and the domes, Buckminster Fuller is just he was a polymath. He was exceptionally talented in so many realms, but he was so far ahead of us. He was like Nikola Tesla, not the company Tesla, but the scientist Tesla, who we look at as being a bit of a crank, like when we look back, but he was eccentric because he was so far ahead of us. And we're only now catching up to the things that he was talking about inevitably happening 100 years later. And Buckminster Fuller was the same way. The Geodesic Dome as an idea, as a design innovation, it's the most efficient space with the least surface area and the strongest surface area with the most interior volume of any shape humans have ever imagined. And we couldn't build them for a while because they were leaky, right? It doesn't have a conventional roof with a drip line to keep things. And now what's happening is we have innovations in material science that are allowing us to finally realize the vision that Buckminster Fuller had. And that's where this company that's doing the bioceramic, it'll effectively be like a monocoque dome, one solid material. And they're going to have electrochromatic glass where the windows themselves can like basically blank out or let the light in with an electric current. It's really fascinating stuff. I'm very excited about where the technology is going to go.
Thank you.
Yeah.
Thank you, Alice. The last house that my late husband and I built on Northwest 24th Street in 1999 was rated an Energy Star home. But there have been many improvements since then in terms of air conditioning efficiency and the on-demand water heating system. I now live in a 20-year-old house that nobody's ever upgraded, and I'm in the process of spending a lot of money. Richard Petway, question, Richard?
Okay, yes, thank you. Hal, what a wonderful job that you can talk so fast in a short period of time and get over so much of the material. I have two questions. One is an easy one. It's a question of fact. The other is more along philosophical lines when democracy in the United States is under threat. So the first one is, do we have any wind turbines offshore in Florida? That's
a pretty quick answer. I can say my current understanding is that we do not. In fact, I think we may not have any offshore wind turbines in US waters yet, but I do believe one project was recently approved at a federal level. I see John nodding his head. So yeah, so I think it's coming. It's been a slow slog to get the policies and the regulations to kind of come in line, but I think we're about to see that take off, hopefully.
Yeah, because if you fly into Copenhagen, you just see in the Baltic a huge amount of wind turbines. Let me go to the harder question, and it's due to the malaise that we're finding ourselves in politically at the present time when democracy may be under threat. But I'm saying it's just almost impossible to cover such a complex topic as what should we do to save the planet. when there's so many alternatives. And I kind of want to, Phyllis raised this a little bit herself, but I wanted to specialize it into a political structure that we can't do anything because of the deadlock in the House and Senate issues. And I guess to some extent, one of the ways that we have accomplished things in the past was to bring a special commission, like to develop the internet, such as in various things, or presidential commission or something like that. So I'm really trying to kind of ask, is there a way around the impasse, the political impasse, that seems to have gotten a lot more severe? And it's, Phyllis pointed it out that one of the Democrats owns a lot of coal mines.
Yeah.
Manchin.
Yeah.
His entire welfare and wealth is tied up in coal mines because he's from West Virginia. He doesn't want to lose that income. The other side is, one of the thoughts was, when you have such a complex problem, you break it up into parts and try to get the easiest done quickly. And I guess in your case, there was a holistic approach, which to some extent yet nets zero, in the sense that it's so complex and so many trade-offs, and we can't get a legislation to even get through Congress if it's too complex. So I guess I wanted to back into Phyllis's question, which is the political reality is really disappointing now, and I just find that these complex problems are just not going to get solved because of lack of action. Biden's agenda is just dead at the present time, and I don't know how we proceed. And so comments on that matter I would appreciate.
Sure, Richard. I really appreciate your comments and your statement. I appreciate your patience in getting to ask the question. I also teach, in addition to some of these like technologically focused things that we've talked about today, I teach a class at UF called Social and Cultural Sustainability in the Built Environment. And I tell the students all the time that that class is probably among the most important classes that they're going to experience, because I think that the technology in the sort of technosphere and the cybersphere, those things are working themselves out slowly but surely. And it's these aspects of our society and culture and our public discourse that concern me, and I'm deeply concerned. And I'm but I also think that things are cyclical. And I think there's a famous quote from Mahatma Gandhi that tries to sort of help ground the different phases of grief and things that we go through, as we try to manifest social change. And he says there's sort of 4 phases in social change. First, the status quo ignores you. Then they laugh at you. Then they fight you. And then the change wins. The change happens. And right now we're in the then they fight you phase. And I try to tell the students in a hopeful way, this is a really scary phase. I mean, it's kind of like a near-death experience in what we want to usher into the world with all of these sustainability innovations and a more holistic and loving and compassionate society. And I think that the old status quo is fighting really hard to hold on to the way of life that they've had, because it's slipping away. And I think in some ways to sort of honor like the place where they're coming from, I think they're fearful. I think they're scared that their way of life is crumbling away. They're scared, I'm a heterosexual white male, and I tell my students all the time, I'm increasingly aware of the place of privilege that I've occupied in my life. unbeknownst to me. I know I fortunately grew up with two older sisters and a very amazing mom, and I've got two daughters, so I'm surrounded by amazing women, and I think that's made me a more complete person because I recognize the things that are feminine and masculine about me. I grew up hunting and fishing, and I love, things that are sort of prototypical, stereotypical masculine things, and then I also love theater and dance and all these things that I fell in love with because of my exposure to to the things that my sisters loved. And I said that I think all of us are both and. We all have some things that we hold on to in tradition, and we can call that conservatism, and then some things that we wish would change faster, and we call that progressivism. And I think we need to stop like pitting everybody in this us versus them and realize that we're all trying to figure out a way to make ourselves whole. And I really think that the old guard is just fighting hard because things are slipping away. And I hope it doesn't get uglier, in the process, but eventually it's going to get better until it gets ugly again at some future point. I mean, I think it's all cyclical. But I think your concerns are really, I think that's the front line of sustainability right now. And for me, it's interesting. I came into sustainability through green building, because my background construction management. And I think I've come to realize that for me, the front line of sustainability is now sort of food and agriculture, because it's something we all have this deep, almost like religious relationship to. We hold on to our food values very strongly. And I think food historically has also been a bridge builder between cultures and communities. And that's what's great about America is it's this melting pot of people, and it's a melting pot of food. That's why I love American cuisine, because it's basically global cuisine. We celebrate everything. And I actually have some slides in here about that. And there's a great show about that if you're interested on Hulu called Taste the Nation with Padma Lakshmi. And she goes around the country and talks about the multicultural heritage of food in our country and what makes it so special. And it's a beautiful show. So I think the things that unite us are deeply more, have much deeper roots and stronger connections than the things that divide us. And I'm confident that we'll make it through this. I just, I hope it's not more painful than necessary to make it through it.
Tom George had his hand up, but then he took it down. Tom, do you want to pose your question?
Well, yeah. Thank you for a great lecture, Dr. Knowles. This is something we don't have very much positive about this event, and I think your talk gave us something positive to think about, and that's really great. I got a couple of personal experiences. I was up in Block Island a few years ago, about 3 years ago, and that community put 3 or 4 wind turbines out. And they were buying all their power from, I think, New England Power. And now, not only they're supplying themselves with power, but they're selling it back to New England Power, which I think is ironic. And I am a Tesla owner. I have a Model 3, and you can charge other cars at Tesla. The only thing is you have to have a Tesla account to pay for it, and that's a stumbling block in it. But on one of my trips, I took a 5,100-mile trip, and I stopped at a supercharger, which is 250 watts, a number one, and it put 200 miles or equivalent of 15 gallons of gas in my car in 22 minutes. I think I went and got a cup of coffee, came back out, and I was amazed how fast it was. Now that cost me $6.24. What would 15 gallons of gasoline cost today? Over $3 a gallon. It would be over 45 bucks. That's the difference in the efficiencies of the EV versus a combustion engine. And that's, another thing, the emissions, zero emissions. I mean, we have catalytic converters and everything on cars, but still they pollute. So, and thank you again for a great lecture.
I have a Prius. I put 9 gallons in the tank. It takes me 450 miles.
Yeah, it's amazing where things are going. Thanks so much, Tom, for sharing your personal experience in the Tesla and that 5,100-mile journey. That sounds amazing. I used to be very worried about energy transition and the energy consumption of our built environment and the energy consumption of our vehicles. And I'm increasingly excited about where things are going. The speed at which a colleague that I work with, he's now retired, Dr. Wendell Porter, he did some analysis and sort of came to see numbers that suggested that the adoption rate of solar photovoltaics is exponentially faster than the adoption rate of mobile phones at a global level. And if you realize that we have, several billion mobile phones at a global level, it's kind of like, it's crazy to imagine where solar PV is going to be in the next 10 to 15 years. I mean, it's happening very fast. And I also think that we now have rounded the curve with EVs. There's in some of these like economic and social science theories about how change happens, they talk about when a technology gets adopted, it's not, the inflection point where that adoption becomes inevitable to be a complete paradigm shift is not at the 50% threshold. It's not when 50% of the population adopts this new thing. It's actually somewhere between 5 and 10% of the population adopts the new technology, and it inevitably is the paradigm that will replace the old thing. And we are now at somewhere about 4% EV adoption in this country. And if you look at Norway as a harbinger of what's going to happen in this country, I think last month they had like maybe 5 to 8% internal combustion vehicles sold, and like 85% of all new vehicles in Norway are now EVs. And they had that 5 to 10% range maybe 3 or 4 years ago. So I think the EV adoption rate is going to happen fast, and I think that the companies that don't make moves quick, I think Ford is an example of a domestic company that's being very aggressive, and kudos to them. I wish they'd have done it earlier. I'm glad that Bill Ford, the current, the descendant, great grandson of Henry Ford, has always been deeply interested in sustainability issues. And I'm glad he finally gets to kind of be a leader in this transition in his own company. And I saw there was a question here from John. I'll do my best, John. You sound like you really are dialed in on these stats. So please correct me if I misstate anything, but the comment about the F-150 Lightning, it's their new 100% battery electric truck. They are now building them, and they will be delivering them this model year. And the vehicle has an optional add-on called Pro Power, which has a bidirectional inverter on the truck. So the truck can plug in and charge at home, but it can also, and they have a special charger that they will install through the company Sunrun that they have a relationship with. When the house goes down, just like a Tesla Powerwall can watch when the storms come through, and they basically will turn on, they'll charge up from the grid and be fully charged and then be ready to turn on when the storm might knock power out. You can have your F-150 Lightning plugged into the house, and it will basically be a stationary battery to power your entire house off the truck. And yeah, go ahead, John.
Did you say for 9 days?
Somewhere, but depending on the house, somewhere between 4 and maybe 8 days. So right now
that'd be about 300. That'd be about 300 kilowatt hours. That's a lot.
So my house, let's see, my house is. It would be probably somewhere between 3 and 6 days. I think I probably overstated it just a hair. So we typically consume about somewhere between 20 and 24 kilowatt hours a day on average in this house that I'm in. And it's a 2,500 square foot, 60s era block house here in Gainesville. And so if you took 24 okay. And yeah,
I'm not gonna, those are details on it like that. Most people are about 33 kilowatt hours a day.
Okay.
For a 2,500 house like that. Perhaps we can share email addresses through somebody here, because I'm pretty familiar with all the things that Enrwell's doing. What do you call it? I also saw in your things you have a kilowatt meter.
Yeah. Phyllis has my permission to share my email with any one of you that participated, if you'd like. I get a lot of correspondence.
What the power companies are doing, what do you call it? And I do think that we're probably way too pessimistic. There's a lot going on, what do you call it? And there's a ton of stuff that's going in everywhere, all over the country.
Yeah.
But the transition is going to be gargantuan. Just to replace the existing grid is going to be about $4.5 trillion. And EPRI looked at, when you take the rest of what you're talking about, which means the transportation, what do you call it, the housing and everything, by 2040, like in there, you're going to need 60% more energy than you have today. That is a gargantuan, what do you call it, job to do. Not that it can't be done, but you got to have some patience, what do you call it, and not let's not make it political at every turn and point fingers, what do you call it. The stuff is happening.
On the
I
other
agree.
hand,
Yeah,
on the
great.
other hand, apparently at
Oh.
the behest of Florida Power and Light, there is bills in the Senate, the Florida Senate and the House, which will change the net metering for solar panels and make them financially inaccessible.
So I can give you some
I
good
have to
news on that
comment on that
exact.
too. I'm sorry, but that's the fourth time I've heard this. The argument the Florida Power and Light's making is that what do you call it, that you're subsidizing one class of customer from the next. Somebody who puts power, the net metering, you sell back to the utility at a retail rate. When the power industry actually can produce that next watt at 1/5 the cost that you can do on your roof. Okay, so why would you have you sell it back at a retail rate, what do you call it, and the rest of the 5 million customers out there are subsidizing you? It has nothing to do with solar power or anything else. FP&L is putting in 40 million solar panels. Their parent is the biggest provider of renewable energy in the world. They're not against solar
Well,
power.
I'd like more education about that, because
No,
apparently I've got,
I'm here to educate you because I've been in the power industry for 40 years. I worked for Florida Power and Light for 30, and I've
Okay.
followed all the technology, including the battery technology, all the way up into the current day
Well,
with
let's
people
have
that
a-
are in it.
let's have a personal conversation about this. It's now 3:15.
Yep.
Our loyal facilitator has left us. And,
Phyllis, could I make one quick comment on your statement? So I put a link in the chat thread, a recent ruling in Arizona. So basically they had a utility that was starting to try to charge customers additional surcharges for having solar PV in their homes. And it was found to be illegal and breaking antitrust laws, basically monopolistic laws for the utility to do this. This ruling is, if it holds up, if it goes all the way to the Supreme Court and it holds up, this will be a profoundly important ruling for all households nationally, because it will basically mean that what Florida Power and Light, or whichever utility, I can't remember the one you mentioned, pushing this legislation in the state to try to kind of minimize net metering, it will freeze those things in their tracks, and net metering, in some form or fashion, will probably still have a life going forward. Utilities are not going to be able to tell people they can't put solar in, and they're not going to be able to charge us more for having it. It sounds like that's not going to hold up in a court of law.
You're missing the point. The point is the price, not the net metering. It's the pricing of it, whether you price it as at the wholesale value or what the next watt would actually cost the utility to produce it at, or do you buy it at net metering, what do you call it, which the net metering or the price, the retail value includes all the other costs that the utility actually has to do to deliver it to you. Okay, maybe you and I should have a separate conversation on that. It gets much more complicated.
No, absolutely. Yeah. And I'm certainly not an expert in utility infrastructure, John, and I would probably default to your perspective in the sense that you've worked for utility for a very long time. And but yeah, it is complicated stuff for sure.
okay, thank you so much, and have a wonderful evening. And thank you for all the effort and time that you've given us for this. I think it's been extremely educational. And thank you, everybody, for attending. Good evening.
Thank you, everybody.